Welcome to this mathematics revision lesson with Was Moses, a mathematics teacher. Today we are going to be looking at solutions to past GCE questions in additional mathematics. And this paper is GCE 2021. Before you begin this lesson, for those who are not yet part of our channel, please don't forget to click on the subscribe button below. The paper normally consists of 50 MCQ, multiple choice questions. So we begin. Question 1. 1 over a to the power n is the same as, when we look at this question, you see that is a fraction whose denominator is expressed in index form. But when we look at the solutions, all the solutions except C, all the other solutions are strictly expressed in index form with A as the base. So how do we make this number to have A as a base and be expressed in index form? The law of negative exponent states that when we have an index in the denominator and the numerator is 1, that base of the index in the denominator becomes the entire base and the index becomes negative. So that one becomes e to the negative n, as the solution clearly shows. Using the law of negative exponent, 1 over a to the power n is equal to, you see that the base in the denominator is maintained. Now, this n, which is the power, becomes negative n. Good. And our answer is B. Question 2. Given that log the square of p is equal to r, then looking again at the answers, you see that what is required of us is that we express this logarithm in index form. And how do we express the logarithm in index form? Solution. We know that the result of a logarithm is an exponent, meaning that if log the square of p is equal to r, then expressing in index form, this base is maintained as we have seen here. This answer to the log becomes the exponent as has been said above. And now, meaning that when we take q, which is the base, to the power r, the result is p. So this is how we transform a logarithm into an index. Answer A. Question 3. The root of 54 is the same as, here again, looking at this, you see that 54 is not a perfect square. And so what they simply want us to do is to simplify root 54 in its basic form. And to do that, again, solution, we find the square number whose product with another integer gives 54. When you look at the factors of 54, the only factor of 54, which is a square number, is 9. And 9 pairs up with 6 as a product to give 54. Therefore, to simplify root 54, we have the square root of 9 times 6, which is the same as the square root of 9 times the square root of 6. We know that the square root of 9 is 3, and the square root of 6 remains root 6, since 6 is not a square number. Answer D. Question 4. Given that alpha and beta are the roots of the equation, 3x squared plus 2x minus 5 equal 0. And then the product of the root is solution. The quadratic equation is given by 3x squared plus 2x minus 5 equals 0. Comparing this with the general quadratic equation, we bring out the coefficients. The coefficient of x squared, which is a, is 3. The coefficient of x, which is always b, is 2. And the constant term is -5, which is always c. Roots are alpha and beta. Now, the sum of roots is always related by the expression -b over a. We know that b is 2 and a is 3. So the sum of root alpha plus beta will be -2 over 3. Products of roots, alpha times beta, we know that they are related by the expression c over a. Therefore, to get the product of root, which is alpha beta, we just replace c with the value, which is -5 over replacing a by 3. We have the ratio -5 over 3. Answer D. We move forward. Question 5. The condition for which the quadratic equation ax squared plus bx plus c equals 0, a different from 0 has real distinct roots, where a and b, a, b, and c are constant is. So in this question, they require us to give the condition that will make the solution to this quadratic equation, if it was a particular quadratic equation, to have real distinct roots, meaning that if you were to solve it, it should give 2 values for x as a solution. So we look at the solution. The roots of any given quadratic equation of the form ax squared plus bx plus c equals 0, a different from 0 satisfies the following condition. If the roots are real and equal, the condition is that, please take notes on the condition. Real and equal, we have b squared minus 4ac equal to 0. For the roots to be real and equal, we just need to verify this quantity. If the roots are real and distinct, given the equation, we just verify this condition, this quantity, and show that b squared minus 4ac is greater than 0. And this is the case for real and distinct. Now, if the roots are real, just real, then b squared minus 4ac is greater than or equal to 0, which means that saying the roots are real, we combine the first 2 conditions above. So roots being real implies that b squared minus 4ac is greater than or equal to 0. If the roots are non-real or imaginary or complex, then this quantity called a discriminant b squared minus 4ac is less than 0. So this is a situation for non-real, complex, or imaginary roots. But in this our case, we were given that the roots are real and distinct, which means that the condition for this particular question is this: b squared minus 4ac is greater than 0. Answer B. Next question. The quadratic equation whose sum and products of roots are 4 and -5 respectively is, here we are required to form an equation, so much so that when that equation is solved, the answers will be 4 and -5. And how do we do that? Solution. Standard form of any quadratic equation whose sum and product of roots are given. No, please. There is an omission. These are the sum and the products of the roots. These are not the roots. So when you form the quadratic equation and you solve, you're not going to have 4 and -5, as I earlier said. So you're instead going to have roots whose sum and product will satisfy these values. Thanks for that correction. We continue. We are saying that standard form of quadratic equation with sum s and product p of roots is given by x squared minus sx plus p equals 0. Now s is equal to 4 and p is equal to -5. Substituting s equals 4 here and p equals -5 in this standard or general equation, we are going to have that x squared minus 4x minus 5 equals 0 is the equation satisfying the roots, the sum and product of roots given by 4 and -5 respectively. So answer D. We move on. Question 7. Given that x plus 2 is a root of, is a factor of x cubed plus kx squared minus 4x minus 4, then the value of k is, let f of x equal x cubed plus kx squared minus 4x minus 4, meaning that this polynomial like this, we let it be f of x. And if this is f of x, we are told that x plus 2 is a factor. And if x plus 2 is a factor, it means that at x equal -2, f of -2 will be equal to 0. Now the question we should ask ourselves should be, how do we have x equal -2? So we simply just need to take this factor x plus 2 and equal to 0. Subtracting 2 on both sides will imply that we'll have x equal to -2. So this is how x equal -2 was obtained. And now, if this is actually a factor, then by the factor theorem, f of -2 is supposed to give us 0. But what is f of -2? F of -2 means that where we have x in f of x, x should be replaced by -2, as you see me underlining. Now simplifying, -2 cubed is -8. -2 squared is 4. -2 times -4 is 8. And -4 is -4 is maintained. So -8 plus 8 gives 0. We're left with 4k minus 4. But by factor theorem, we're saying that f of -2 is supposed to be 0. So that is why we say that is 4k minus 4 is equal to 0, because by factor theorem, f of -2 is supposed to be 0. And if we add 4 on both sides, adding 4 on both sides, this 4 disappear and you have 4k equals 0. Dividing both sides by 4. If we divide both sides by 4, 4 cancel here, 4 cancel here to give 1, 4 here, 1, 4 into itself, 1. So giving k equals to 1. Answer C. Next question, question 8. The remainder when x squared plus 4x minus 7 is divided by x plus 1 is solution. Again, this question 8 is almost like question 7, but the difference is that x minus 1 in this case is not a factor, it's a divisor, which means that the remainder will not be 0. Let f of x equal x squared plus 4x minus 7. Divisor is x plus 1. and at x equal -1, f of -1 gives the remainder. So in this case, how again do we obtain x equal -1, given that this is a divisor? To obtain the value of x when the divisor is given, we just again take the divisor, same thing we did with the factor. You take the divisor, equate it to 0, and find the value of x. X plus 1 is equal to 0, implying that x is equal to -1. That is how we obtain x equal -1. And now, at x equal -1, if we find f of -1, we will obtain the remainder. What do we now do? We go to f of x and we substitute x equal -1. If we go to f of x, substitute x equal -1, we are going to have -1 squared plus 4 into -1 minus 7. -1 squared gives 1. 4 times -1 gives -4, and negative minus 7 is maintained. 1 minus 4 gives -3. This gives -3 minus 7. Answer -10. So the remainder is -10. Answer B. We move to question 9. UN equals 2 to the power n plus 1 all over n plus 1. And then U3 is equal to, so this is the formula of the nth term of a sequence, UN. Now we want to obtain U3. Solution. When we have UN equal to 2 to the power n plus 1 over n plus 1, U3 simply implies n is equal to 3. So the value of that UN, meaning that the term in that sequence where n is 3, the term in that sequence where n is 3 is supposed to be the third term. So the third term will be simplified when we substitute n equal 3. So U3 will be 2 to the power 3 plus 1 over 3 plus 1. And we know that this is what? 2 to the power 4 over 4. And we know that 2 to the power 4 is 16. 2 to the power 4 is 16. So 4 here, 1, 4 into 16, 4. Answer 4. So the answer is C. Next question. The geometric mean of 4 and 16 is solution. Generally, the geometric mean GM of two numbers P and Q is given by GM equals the square root of the product P times Q. And as a remark, when you are looking for the geometric mean, at the end, know that if the geometric mean of x, 4 and 16 is to be x, know that when you place x in between 4 and 16, the three terms must form consecutive terms of a geometric progression. Otherwise, that number you put in between, or that number you obtain as the geometric mean, will not be the geometric mean. So now the two numbers are 4 and 16. Thus, geometric mean will be the square root of 4 times 16. This is simplified as the square root of 4 times the square root of 16. And we know that the square root of 4 gives 2, and the square root of 16 gives 4. So 2 times 4 is 8. Answer D. We move to question 11. The summation from r equals 1 to 5 of r minus 1 is equal to, okay. Now, this sum means we need to substitute R here equal 1, R equal 2, R equal 3, R equal 4 to R equals 5. And if we substitute R equal 1, we have 1 minus 1, and it gives us 0. R equal 2, we have 2 minus 1, which gives us 1. R equals 3, we have 3 minus 1, which gives us 2. Substituting R equals 4, we have 4 minus 1, which gives us 3. And if we substitute R equals 5, we have 5 minus 1, which gives us 4. Okay, now this sigma means we add. So the summation from R equal 1 to 5, R minus 1 is equal to 0 plus 1 plus 2 plus 3 plus 4, giving us 10. Answer C. Question 12. The sum to infinity of a geometric progression with first term 6 and common ratio 1/3 is solution. Sum to infinity of any geometric progression with magnitude of R less than 1 is given by S infinity equals A over 1 minus R, where A is the first term, R being the common ratio. Now, A is equal to 6, R is equal to 1/3, which satisfies this condition for the sum to infinity. Thus, the sum to infinity will be equal to 6, which is A. We simply just replace A with 6 in that formula, and we replace R with 1/3 to give sum to infinity equals 6 over 1 minus 1/3. 6 over 1 minus 1/3. Yeah, 6 over 1 minus 1/3, which is equal to 6 over 1 minus 1/3 is the same as 3 times 1, 3 minus 1, all this over 3. And this gives 6 over 2/3. And 6 over 2/3 is the same as 6 times 3 over 2. Now, 2 here, 1, 2 goes into 6. 3 times, and 3 times 3 gives 9. So the answer is B. We move to question 13. The first 3 terms in the binomial expansion of 1 plus x, all this to the power -2 are generally the expansion of 1 plus x to the power n is given by 1 plus nx plus n into n minus 1 over 2 factorial x squared, plus it continues in that pattern. Now, 1 plus x to the power -2, we see that this n is -2. So we just replace all the n's we have here by -2. We replace all the n's by -2. And when we do that, we have 1 plus -2x plus -2 into -2 minus 1 over 2 factorial x squared plus continuous. Since we are limited to the term in x squared, we have 1 minus 2x plus 3x squared plus blah, blah, blah. And the answer is B. Question 14. The number of terms in the binomial expansion of 1 plus 3x to the power 9 is solution. Generally, in the expansion of a plus b, all this to the power n, there are always n plus 1 terms. And just to refresh our memories, if we go back to the question we have just solved, question 13, you see that we were looking at, we ended with a term in x squared, the term in x squared. But how many terms were there? 1, 2, 3. So we are ending with the term in x squared. We have 3 terms. Square is 2, and we have 3 terms, meaning 2 plus 1. So coming back now to the number of terms in the expansion of 1 plus 3x, all this to the power 9, we see that the number of terms will simply be what? 9 plus 1, which is 10 terms. Question 15. The number of ways in which the letters of the word tangent can be arranged is the word tangent. Solution. Word tangent is spelled T-A-N-G-E-N-T. We see that number of letters found in the word are 7. There are 7 letters in that word. But out of the 7, the T and the N's are repeating. So we have 1 T, 2 T, 1 N, 2 N. So we have 2 T's and 2 N. So thus the number of ways of arrangement will be given by first arranging all the 7 in the straight, which is 7 factorial, over arranging the ones that are repeating, 2 factorial, 2 factorial, N's in 2 factorial ways, T's in 2 factorial ways. So giving us D as the correct answer. Question 16. The number of ways in which 5 girls can be selected from a class of 8 girls is solution. Total number of girls equals 8. Number of girls to be selected, 5. Number of ways of selecting 5 girls from 8 is 8 combination 5, meaning choosing 5 out of 8. And the formula for combination says that this 8 combination 5 is expressed as 8 factorial over 8 minus 5, all that factorial times 5 factorial. And 8 minus 5 is 3 factorial. 8 factorial over 3 factorial, 5 factorial. Answer C. Question 17. Tan 30 degrees is equal to 30 degrees is a special angle. So for special angles, we look at the 3 special angles, 30, 45, and 60. Look at the table. These are the trig ratios, sine, cos, tan. Now, theta, when theta is 30 degrees, we will follow each trig ratio and see the value when the angle is 30. Now, but we're interested in tan theta being 30. So we're interested in having tan 30 degrees. And looking down, you see that tan 30 degrees is root 3 over 3. So the answer is D. We move on to question 18. 240 degrees in radians is, generally, when we have an angle in degrees, to change an angle in degrees to radian, we simply multiply by pi over 180. Now, if we have an angle in radians, to change to degrees, we multiply that angle in radians by 180 over pi, and the result is in degree. Thus, 240 degrees, which is an angle in degrees, to be changed to radians, the theta here is replaced by 240 degrees. We simply just replace and we multiply by pi over 180. 0 cancel 0. 6 here, 3 times. 6 go into 18 3 times. 6 go into 24 8 times. So please, 6 goes into 24 4 times, please. 6 goes into 24 4 times. So the answer now is 4 times pi, which is 4 pi, and the denominator is 3. So answer 4 pi over 3, which gives A. We move to question 19. The quadrant in which sine theta and cos theta are both negative is solution. Analysis of the signs of trigonometric ratio in all the 4 quadrants. Please take a look at that. This is called the first quadrant, and in the first quadrant, all the trigonometric ratios are positive. In the second quadrant, only sine is positive, meaning cos and tan are negative. But we want a quadrant where sine will be negative, so this 2 is rejected. The third quadrant, only tan is positive. Then, if they say only tan is positive and there are 3, it means that cos and sine are negative. And we are looking for the quadrant where cos and sine are negative. So, which means that our result is the third quadrant. Answer C. Question 20. The area of the minor sector OAB. This is the minor sector OAB, this region, of a circle with radius r that subtends an angle theta at the center O is, please, looking at this geometry, you see the shaded region in red. That is the required area we want to calculate. So we know that the ratio of each part of a circle, of the area of each part of a circle to the area of the entire circle, must give the ratio of the corresponding angles subtended by that part and the entire circle. So area of sector OAB over area of circle is equal to theta, which is the angle subtended by that sector, over 2 pi, which is the angle of the entire circle. Now, area of minor sector OAB will now be equal to, you cross multiply the area on both sides. You cross multiply the area on this side, knowing that this area is pi radio square. We know since from primary school that area of a circle is pi radio squared. That is why we have theta over 2 pi times pi radio squared. Pi cancel pi. We are left with theta r squared in the numerator. The denominator we're left with 2, which can be expressed as half r squared theta. Answer G. Question 21. Cos P minus Q is identical to, these are half angle, compound angle identities in trigonometry. So using the compound angle identity, we know that cos P plus Q is identical to cos P cos Q minus sin P sin Q. Cos P minus Q is identical to cos P cos Q plus sin P sin Q. Now, looking at the question, we're asked to expand cos P minus Q, which means that this is our result. Answer A. Question 22. From the diagram, the site B is given as, when you look at the diagram, you discover that the diagram is that of a triangle. And when we are solving triangles, either finding the sides or the angles, there are 2 rules. Either we use the cosine rule or we use the sine rule. And then looking at B, to find B, since we know these 2 sides, we need the angle at B. So we need this angle. If once we get this angle, we use the cosine rule. And looking at the answers, you see that the answers are given in terms of the cosine rule. So you take a look. From each side on the triangle, we use the cosine or the sine rules. This is a statement of the sine rule for revision purposes, but here we are concerned with the cosine rule. And the cosine rule, we need to find the side B. What is the relation between the side B and CA? This is the relation. B squared is equal to A squared plus C squared minus 2AC cos the angle at B. So looking at the answers, we see that the best alternative is B. We move to question 23. The midpoint of the line joining the points P with coordinates 3, 7, and Q with coordinates 5, 9 is solution. The coordinates of P 3, 7 can be renamed as x1 equals 3 and y1 equals 7. Coordinates of P 5, 9 can be renamed as x2 equals 5, y2 equals 9. Now the formula for finding the coordinates of the midpoint of a line segment PQ when the 2 points are given is given by x1 plus x2 over 2, y1 plus y2 over 2. Now, substituting x1 equals 3, substituting x1 equals 3, as we have seen above, x2 equals 5, y1 equals 7, and y2 equals 9. We have 3 plus 5 gives 8 over 2. 7 plus 9 gives 16 over 2. Now, 2 here, 2 cancel itself 1 times into 8, 4 times. 2 goes into itself 1 time into 16, 8 times. And the coordinates are 4 and 8. Answer B, 4, 8. Question 24. The perpendicular distance from the point 3, 7 to the line 4x minus 3y plus 21 equals 0 is? Now, solution. The line is such that 4x minus 3y plus 21 is equal to 0. Now, given the point P 3, 7, we rename it to have x1, which is 3, y1, 7. For the line L, perpendicular distance, for this particular line L, if we are looking for the perpendicular distance, we use the formula G, which is supposed to denote the perpendicular distance from a point x1, y1 to this particular line will be given by 4x1 minus 3y1 plus 21 all over 4 squared plus negative 3 all squared. Why 4xy1 and 3y1? Looking at the line, you see that what we are doing is all the numbers on the equation of the line are maintained, the 4 and the negative 3 are maintained, but only the x and the y are changing and being replaced by the coordinates of the point that has been given, the point at which the perpendicular distance is calculated. Now, simplifying, we have 4 times 3 minus 3 times 7 plus 21. 4 times 3 gives 12. 3 times 7 gives 21. Negative 21 plus 21. This cancel this to give 0 here. And what we are left with is 12 over 25, the square root of 25. And the square root of 25 is 5. So the answer is 12 over 5. And it is A. Question 25. The equation of the straight line with gradient negative 3, which passes through the point 1, negative 2 is? Solution. Equation of any straight line passing through a point x1, y1 with gradient m is given by y minus y1 equals m into x minus x1. Now, m is equal to -3. The gradient is -3. The point is 1, -2, implying that if we rename this point, we'll have x1 to be the x coordinate 1 and y1 to be the y coordinate -2. And looking at this general equation, when a point is given and the gradient is known, we simply replace y1 with what? With this -2. We replace m with -3, which is the gradient, and we replace x1 with -1. Now, simplifying, y minus -2 gives y plus 2, -3 into x minus 1. -3 times x, to expand this, we have -3x, -3 times -1, we have 3. And the answer is y equals -3x. When we subtract 2 on both sides, we have y equal -3x plus 1. We have come to the end of this first revision. The second revision part of the revision will be from question 26. Thanks for viewing. And if there are any questions, you can post them in the comment. Thank you once more for viewing.